So this is going to be the second half of our continued 4.4. So the third video relating to 4.4, which is all building on the idea of vertex form of our quadratic equations. So our previous example looked specifically at systems of equations and how we can use them to determine multiple pieces of information about our quadratic if we're not given them. So this is probably one of our more complex examples in terms of building our equation. Example 3 is a little bit less difficult because we're given the vertex. So that's 2 out of the 3 pieces we need to be able to identify to fill in vertex form. And that is our vertex, which is +5 and -4 in this case. So I can already start filling in my quadratic equation. I'm subtracting my p-value, which is 5, because it's positive, it stays negative in the equation, and then I'm going to subtract 4. But I am not done here because my a value still isn't accounted for, so I need to solve for that as well. So I can choose any point. This one is nice and clearly defined at 2 and -1. So that's the other point I'm going to use. I'm going to plug those in for x and a y and solve for a. So again, -1 equals a, and then I've got 2 minus 5 squared minus 4. Moving my 4 over, add it, so I'm going to have +3 equals a, and then -3 squared, which is 9, which means that I've got 3 equals 9a, divide by 9, and we get 1/3 is a. Once I know what my value of a is, that's my vertical stretch or compression, I can complete my equation by filling it in addition to my vertex. And that'll be my equation for that first graph. So we can use the exact same properties looking at part B. I'll note that I already know that a should be negative because it's opening downwards. So just as a reminder to myself, so that when I actually do the math to make sure that I've gotten the correct value for a in the end, I'll apply what I already know. Otherwise, I identify my vertex, which is 0 and 3, which means I start by filling in a x plus 0 or x minus 0, whichever way of thinking about it, still is just x, so it's ax squared plus 3. So it almost kind of looks like general form there too, and that's why our q value actually ends up being our y-intercept as well, because we have no horizontal shift. Again, I choose a point, and I'm going to plug it in. So in this case, I chose -1 and +1. Now be careful when you're reading these graphs. In the first graph, the scale on my x-axis was 1. The scale on my x-axis in part B is actually 1/2. So be conscious that you're always reading by the scale, not just by how many squares you've counted over, because they don't always mean the same thing. So I'm going to plug in my values. 1 equals a times -1 squared plus 3. Move my 3 is -2 and 1a. So a is -2, which means my final equation is going to be -2 x squared. Sorry, I'm having troubles with my stylus still. Y equals -2x squared plus 3. There. And so that gives us our two equations for those two parabolas. So it's a little bit simpler than when we're working from our axis of symmetry where we're not even given our y value, and also trying to find our a value at the same time. Okay, so looking at these values now, we're going to just be determining the number of x-intercepts using A and Q. Now, I've already kind of alluded to this without actually mentioning those specific values, but now we're going to use them for the purpose of identifying our x-intercepts. So we've got A is 0.8, which means it's positive, it's opening upward. Q is -3. That means that it's below the x-axis. Because of this, I know it's opening upward in this general direction. That means I'm going to have two intercepts. So that combination of upward with my vertex below the x-axis, that implies that I'm going to have two intercepts for my x-axis. Alternately here, my a value is 2, so it opens upward. My q is 0, which means that my vertex is resting on the x-axis. If my vertex is resting on the x-axis, we've already seen this, but just to confirm, it looks like that, which means I've only got one point of intersection, so I have one x-intercept when my vertex is on the x-axis, when q equals 0. And that would actually work for opening upward or opening downward. Finally, looking at this last equation, A is -3. That tells me that it's opening downward. My Q value is -1, which means it's below the x-axis. So with that in mind, if I tried to sketch it out, it would look something like this, and I no longer have any x-intercepts. So that's how we can use A and Q to determine if we have any x-intercepts. Kind of in the same vein as our discriminant, just a little bit more in the observation and application of our observation skills as opposed to number crunching. So you've got lots more time to practice. Those were the last couple examples. So give the practice questions for homework a shot, and make sure you're feeling pretty comfortable with this whole idea of transforming our parabola.